Good morning, everyone. My name is Saiteja from ACC B section. Today, my topic is operational amplifier and AC characteristics. Operational amplifier op amp is a DC coupled high gain electronic voltage amplifier. The direct coupled high gain amplifier usually consisting of one or more differential amplifier designed for computing mathematical functions such as addition, subtraction, multiplication, integration, and differentiation. And the given below IC is 741 IC. The block diagram of IC consists of two terminals, non-inverting input and inverting input, where these are as connected at input stage, and then the follows to intermediate stage, and then next level shifting circuit and output stage. Input stage is a dual input balanced output differential amplifier. This stage provides most of the voltage in the amplifier. Also establish the input resistance of op amp. Intermediate stage. The intermediate stage of op amp is another differential amplifier which is driven by the output of first stage. This is usually in dual input unbalanced output of IC. These are the two. And the level shifting stage. Because direct coupling is used, DC voltage level at output of intermediate stage is well done ground potential. Therefore, level shifting circuit is used to shift the DC level at output downward to 0 with respect to the ground. Output stage. The output stage is generally a push-pull complementary amplifier. The output stage increases the current voltage and raises the current supply capability of op amp to provide low output resistance. Internal circuit diagram. The internal circuit diagram of a given IC is shown in the figure, where this is the input stage, intermediate stage, level transistor, and output stage. Sensor signals are often too weak or too noisy. Op amp increase the weak signal amplitude and reduce its noise without affecting its other properties. Where the strain gauge, transducer, amplifier, signal processor, and recorder. Symbol of IC transistor, and the negative terminal is given as inverting input and the positive given as non-inverting input, and V plus the power supply and V minus is another power supply, and the VO is output of the given amplifier. IC equivalent circuit. V1 and V2 are the two input voltages, where R1 is input impedance of op amp. AD/BD is an equivalent voltage source, and RO in the experiment impedance looking back into the terminal of an op amp. V output is equal to AD into V1 minus V2 into AD into VD, where the equation indicates the output voltage is directly proportional to the algebraic difference between the two input voltages. In other words, the op-amp amplifier is difference between the two input voltages. It does not amplify the input voltage themselves. The property of the output voltage depends upon the polarity of different voltage equivalent of an IC. Minus terminal and plus terminal VCC and minus VC, and the numbering code is given different for the different amplifier. The pin diagram for 741, and the first one is offset and second one is inverting input, third one is non-inverting input, fourth one is minus VC, and the eighth pin is real connector, and the eighth week is seventh is 1B, and fifth is offset null, sixth is output. Application of an IB amplifier. Audio amplifier, instrumental amplifier, power amplifier, analog computers. Ideal op-amp characteristics: infinity voltage gain, approximately 2 lakh, infinity input impedance greater than 100 ohms, zero output impedance is less than 100 ohms, and the infinite CMRR parameter of op-amp. Input offset voltage, a small voltage applied to the input terminal to make the output voltage as zero. When the two input terminals are grounded, in such input offset voltage is same 2 mV for 7V1 IC, and the input offset current, the difference between the bias current at the input terminal of op-amp, is called as input offset current, where II2 equal to IB1 minus IB2. Input bias current at the average value of base current entering into the terminals of an op-amp. IR, input resistance, is an equivalent resistance that can be measured either the inverting or non-inverting terminals. Output resistance is the equivalent resistance that can be measured output terminals and ground terminals. CMRR, common mode rejection ratio, is the ratio of AD voltage gain to the common mode voltage gain. Super voltage rejection ratio, it is defined as the ratio of change in input offset voltage and to corresponding change in supply voltage. Slew rate, it is defined as the maximum rate of change in input voltage. The frequency of the given, the gain is larger at very low frequency. Gain is constant over peak frequency, and after the frequency gain falls down. The unit gain frequency, the F unit is the frequency that gain in unity. Two main characteristics of IC: inverting amplifier and non-inverting amplifier. Voltage at node 1 inverting is given as node at node 2. KCL at node 1 given V0 equal to minus IR1, VI equal to R1. Inverting the phase 180 degrees of phase shift exercise, and the gain is R2 by R1 equal to 150 by 12. Non-inverting amplifier. Voltage at node 1 is equal to voltage in node 2. VI by R1 equal to VI by R1 plus VI plus RL plus V1 VR1 plus VR2. Our input and output wave of non-inverting amplifier. Thank you for giving this opportunity.